Hey, Aaron. Welcome back.
Thanks. You too.
We're gonna give it a few minutes just because, um, I want to see if it's more than just you. No offense, but if it's
Understandable.
just you, then well, in about 5 minutes we'll get started either way.
Cool.
Okay, well, let's go ahead and get started. I think it's just gonna be you, and that's fine. Um, but my cat is sitting, and you're here, and it's 11:05, so let's talk about critical reasoning in reading, also known as, well, pretty much critical reasoning. Basically, the argument section. Yes, Julie is glad. I'm glad. We are glad you were here because if you were not, I would just be talking to myself, and that's weird. Uh, okay, so critical reasoning are the short passages that you see in the reading comprehension for which you generally just get one question. And these are not the traditional reading comprehension. They're less focused on sort of the big picture, scope and tone type of stuff. Um, they're less focused on sort of spotting facts that you read about. They're more focused instead on analyzing arguments. So in order to do well at critical reasoning, you definitely need to be able to break down and understand an argument. Now, an argument is a series of premises that purport to establish a conclusion. The conclusion is the statement of which you wish to convince your listener, and the premises are the evidence that you use to do that. So ultimately, I don't draw a strong distinction between premises and evidence. For me, this is all kind of one and the same, pretty much. Just you know, all this stuff is premises slash evidence, um, and it leads to the conclusion. Um, Now, the distinction is very important because, first of all, if you want to understand an argument, you generally want to start with the conclusion, find the conclusion, and work backwards, and see what the path to the conclusion is. And then you're looking always for gaps. There's always at least one gap in the path. As you're going from, A to B to C, there's a hole somewhere in the argument. You're missing B. So you're like A blank C. And so it's important to be able to identify conclusions and distinguish them from premises so that you can understand that structure. It's also important because while you're allowed to argue with conclusions, you can't question any of the premises. So we need to be able to distinguish between the two. And this is where those indicator words that we've been talking about all this time come back and are very important. Premise indicator words are things like because, or due to, or since, or for. Because, for, and since would be the most common premise indicators. On the other hand, conclusion indicators are things like therefore, thus, hence, so, in conclusion, and so forth. I know it's hard to believe, but when I say the words in conclusion, I am probably, believe it or not, about to state a conclusion. So you can look at these words to help you break down the argument. Let's start by focusing on that. So, therefore, thus, hence, so, in conclusion, etc. You can also think of the conclusion as the author's recommendation. This means that conclusions tend to be more sort of debatable statements, whereas premises tend to be more factual in nature. This is not a hard and fast rule, but it can be a general guideline. Conclusions tend to be opinions. Premises tend to be facts. One other thing you can think of is, where is this whole thing going? The conclusion is sort of the thing at the end of the chain of reasoning. So if you think about what's sort of at the end of the chain logically, that's going to be your conclusion. So oh, and by the way, if you were in middle school, everyone would say, oh, well, the conclusion's easy to find. It's at the end, because of course we always go introduction, support, 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 conclusion, right? Everyone's got exactly 3 premises and then the conclusion. Well, that's not true here. This is not middle school. We need better ways to break it down, and we have them with the indicator words and looking at where the argument is leading and thinking of premises versus, facts versus opinions. So don't assume the conclusion comes at the end. The first can be the conclusion, the middle can be the conclusion, or yes, it can occur at the end. So what I want to do with you, Aaron, a little bit right now is work on breaking down a few arguments and seeing if we can identify the conclusion. So, what, for instance, is the conclusion of this argument? And feel free to hop on the mic and talk, but take a minute to read. Still with me, Aaron?
Yeah, I am. And the conclusion, sorry, my screen is too big for, okay. The conclusion is where it starts saying, of these, the last was likely the least affluent of the three.
Right. But especially this bit.
And most likely Edmund's father since school. Yes.
Right. The ultimate conclusion is that he's most likely Edmund's father. Ultimately, the thing about most likely the least affluent is just how we got to the point that he's most likely Edmund's father, right?
Yeah.
Well, he's least affluent, and, so that's why we think he's the father. Now, one thing you always want to do with these is look for gaps. What, if anything, do you see as potential gap in this argument on the way to this conclusion?
What was the gap?
Yeah, well, what's a possible gap here? There are multiple, but we're always looking for gaps.
Oh, well, um, they, um, well, it's just, I mean, like, it's just a straight assumption. Just
Like
most of,
what? What do you mean it's a straight assumption?
well, but just them saying most likely, they're guessing that his father is the least affluent.
Well,
The
why?
records don't talk about
Why
their,
would his father be the least affluent?
well, they think because the school is giving him a reduced fee.
So, is there a questionable assumption, a gap in there?
Yeah.
What's that?
Well, they're assuming just because he has a reduced fee that he is less affluent.
Right.
Jumping.
They assume that reduced fees are for poor people.
Mm-hmm.
And that's a question, right? Now, one thing you'll note about gaps is that the gaps are going to tend to be in places where you might just generally think that's very plausible and very believable and very likely even. The gaps are going to fit very much with your intuition. That's how they hide them. They hide them behind your own expectations. Well, you think, of course, well, he's getting a reduced fee. I bet he's probably less affluent. But who knows? Like maybe rich people get reduced fees if they're considered scholars.
Mm-hmm.
I don't know, right? That's
Yeah.
probably the biggest gap here. It's not the only one. Any others you notice?
Um, mm, no, not that I know of.
Okay. Well, they said he attended the Merchant Tailors School, but they're talking about being member of the Merchant Tailors Guild. Do only Merchant Tailors Guild members get to attend this school? Maybe the Merchant Tailors School admits some people whose parents aren't in the guild.
This is true.
Also, they're relying heavily on the fact that his last name is Spencer, and they only had three members named Spencer. Is it possible he had a different last name than his father?
Yes.
Okay. Well, that's another possibility, right? So maybe his father wasn't in the guild, maybe his father was in the guild with a different name, or maybe his father was a different one of those, but it wasn't really about the reduced fee because they were poor, right?
Yeah.
And so these are the sorts of games we can play. Question everything they didn't actually say. However sort of obvious it may seem, if they didn't say it, it's a potential gap. Oh, well, of course, your name is Spencer. Your dad's name is probably Spencer. Well, wait, did they say that? Oh, well, of course, if you're attending a merchant tailor school, you're probably in their guild. Well, is that necessarily the case? You know, and
Might
these
not.
are all things we can pick on as gaps in the argument. Comments?
No?
Okay, here's a good one. Let's do this question. This is another one about just sort of breaking down an argument and identifying what parts you're looking at. Take a couple minutes and do this.
Well, the conclusion is after thus, like the last sentence. They should maintain their desired shape more
Right.
realistically than those prepared.
Okay. So I agree that's the ultimate conclusion of the argument. What about the word accordingly? What type of word is accordingly, do you know?
I'd assume it's another conclusion.
It is.
Conclusion, yeah.
Accordingly is a conclusion word. That suggests that this is maybe perhaps not the ultimate conclusion, because ultimately this turns around and supports the last sentence, right?
Yeah, they're kind of, yeah.
But it is an intermediate conclusion. It's an in-between step. So we've figured out the second bold pretty well. It's an in-between conclusion. What about the first one?
The first bold. Do you want me just to kind of label what I think it is?
Yep. What do you think it is?
I would think it's trapped, but I think it's evidence. I think it's a statement of fact.
Again, I don't make an evidence versus premise distinction. I think this is premise.
Okay, it's a premise.
Because there's nothing that supports this, right? There's nothing that establishes that the fact that when they're beaten too long, their protein structure breaks down.
Yeah.
It's
but
just
they're not using it as a conclusion. They're using it as moving towards conclusion. Yeah.
Yeah, it's not concluded based on anything. So the first one's a premise. The second is an intermediate conclusion, and it all supports the ultimate conclusion. Do we agree on that?
Yes.
Great. Do this question.
Well.
Yes.
Sorry, I'm zooming out. Okay, so to break it down, obviously it's not B. Wait, right? The conclusion supplies evidence. Yeah, it's not B because it's not an objection.
Right. There is no objection here. There was never a but, a however, a not, any kind of argument at all.
A is not right because the first one is not asserting the conclusion.
Right. It's not the conclusion. It's premise.
We'll come back to C for a second. D is the first is the supports it further. So it's not D because D it wasn't.
Premise, right.
Yeah, it's not. It's not an intermediate conclusion.
Also, the opposes is wrong.
Yeah. Um, and then E, so it says the position in which the argument overall opposes. It's, again, not opposed.
Right. It's also not really a position. This is more like a synonym position for conclusion.
Yeah. And then, so C, the first part is it supports. Yeah, I like that it says
An
supports. It's a
intermediate.
big one. An intermediate conclusion, which in turn supports a further conclusion as given in the argument. The second is a statement of that intermediate conclusion.
Yeah. That's right. Supports an intermediate conclusion is a fancy way of saying it's a premise.
Yep, yep.
But the second is an intermediate conclusion.
The only thing, the last sentence, the thing that, I mean, like, I got rid of all the other ones, so I knew it was C, but the last sentence says the second is a statement of the intermediate conclusion. I thought the second was an intermediate conclusion that then
Right.
led to the conclusion.
Right. It's an intermediate conclusion. But they said what the answer said was it's a statement of the intermediate conclusion, which is a fancy way of saying it's an intermediate conclusion.
Okay. That was the only thing that I
A statement of that intermediate conclusion. They may use difficult wording here, and they may be kind of vague, and they may, rather than just saying premise, they may kind of tell you what a premise is. Supports an intermediate conclusion is a fancy way of saying, yo, that's a premise. But, like, they're going to do all that to try and throw you off, because this shouldn't be that difficult if you just condense the argument down in this way. And they have to do something to try and make it harder for you. So just don't get beat by that stuff. Look at it and say, what are you actually saying here? Supports a conclusion? Oh, that's called a premise. A statement of the intermediate conclusion? Well, why didn't you just say the second is an intermediate conclusion? I don't know, because they're jerks, but so what? That's fine.
I agree.
Yeah, they're jerks. I agree with that. You agree with that. We all agree. Okay, great. So now let's get in a little bit to the different types of questions here. Strengthen and weaken questions would be the first type. They are looking for you to add something to the argument that is going to bridge a gap if it's a strengthen, or blow it up if it's a weaken. You're going to look for the conclusion, find the path, find the gap, and either bridge it or blow it up. It does not have to prove it or disprove it 100%. It just has to address a gap, and make sure that you address the gap in the right way, because especially on weakened questions, they love to have a sort of backwards wrong answer that actually strengthens instead of weakens, and it's wrong because it's backwards. And remember, if you don't address a gap, even if it's nice, a nice answer that doesn't actually address a gap is a wrong answer. Okay?
Okay.
Do I have one here? That's an inference. Okay. Let's do a strengthen and a weaken, and then we can pretty much move on to math, and hopefully get there a little early again because we got a lot of math today. So try. Hang on. Sorry. Try to decide which one. Let's do the parakeets.
Okay.
Take a minute and read this and think about what the gaps are, and maybe we'll talk about it, and then we'll give you a question.
Okay, you can go to the questions.
Okie dokie.
So I think, well, can you go back to the passage really quick, please?
Yes, I can.
Okay, back to the question.
You got it. Bit of a tough one.
Okay, I know. So, uh, I originally thought A, the amount of zinc used in feed bowls is lower today than the amount used in feed bowls sold 10 years ago because it
Okay.
talked about how it should completely remove or should dramatically reduce the frequency. But then I realized that doesn't actually talk about reducing the frequency of premature death. So
Right,
then,
anyway, the way that they're going to fix things is not by using less zinc, it's by recalling them
yeah,
entirely, right?
yeah,
The conclusion is this.
recall of it
Right,
completely.
so using less zinc, whatever, now versus 10 years ago, is it still enough zinc to cause illness or death or whatever? I don't know, but kind of beside the point, right? Like, I'm
Yeah.
not going to have any zinc because I'm taking the bowls away. So the question I would have is, how would that not solve the problem, right? I mean, you're getting rid of the zinc, aren't you?
How would recalling it not solve the problem?
Yeah.
Well, there could be other ways that the parakeets could get zinc, since they did
Yeah,
assume that.
still,
Oh,
wouldn't that still dramatically reduce the frequency?
you would
Because after
assume.
all, they're still not
And,
getting from their feed bowls. I imagine their feed bowls are a huge way they got zinc. And you've got rid of all that zinc,
yep,
right?
you assume that they're assuming, and that's how they got um, they got the seizures because of the zinc through the bowls, but it, um,
Except they said that as a premise, the only way the birds could have encountered the heavy metal is through the feed bowls. So I'm assuming that because the premise said it, and I can't really argue with the premise.
oh, okay. So then,
So the gap here is not obvious.
um, no, I guess not.
So
Um,
what we really know is we got rid of the zinc-coated feed bowls, and the zinc-coated feed bowls were the source of the zinc. So I now have a fairly paradoxical question. Does that mean necessarily we got rid of the zinc? Put another way, how could it be that we might have gotten rid of the zinc-coated feed bowls that are the source of the zinc, and yet not got rid of the zinc? How would that be possible?
uh, that it, well, C, that the zinc doesn't leave the system after you get rid of the bowls.
Oh, I get it. If the zinc is in the parakeet and it stays there, then will removing the bowls get rid of the death rate since the heavy metal causes damage over an extended period of time? If it's still in the parakeets, will removing the bowls solve the problem?
Well, if the zinc leaves their system, yeah.
Yes, if it leaves their system. And we need to know that, right?
So C, naturally eliminating from the parakeet's bloodstream in a few weeks, would strengthen the
Yes,
argument.
because it fills in a gap. The gap was they said the zinc bowls are going away, right? But they didn't actually say the zinc was going away. And it's such a narrow gap because you're like, oh, well, the zinc comes from the bowls. We know that. So if the bowls go away, the zinc goes away. Well, it comes from the bowls, but once it's there, taking away the bowls doesn't necessarily take away the zinc. I mean, maybe the zinc rubs off on the cage, and then, like, even if you take the bowls away, there's still zinc residue on the cage. Or maybe the zinc gets in their system, and it just stays in their system, causing damage over an extended period of time. Or, like maybe there's some other way that the zinc stays even after the bowls leave. And that's a very, very small, hard to see gap, but it is the gap that matters here. And C was the correct answer. What do you think about that, Aaron?
I think that makes sense.
Are there any other answers we need to discuss here?
No, I was debating between A, B, and C, and like I said, I got rid of A. B, it was just like a broad
I,
one. Didn't actually do anything to the argument. It was
that's
true.
right.
I like went through them all, and like the true ones, I was like, okay, but the other ones I didn't. D and E, I didn't think did anything, and then I went through those. I obviously got rid of A. B, I was like, that doesn't even. It's not the argument or do anything with the argument.
Important principle here, just because it's nice doesn't mean that it's right. It has to deal with your argument, and that especially means it has to address your conclusion. I am sort of ruthless about my conclusion when I'm doing these questions, and I don't care about anything else. My conclusion was that it would dramatically reduce the frequency of premature death among pet parakeets. So you know what I don't care about? Whether I killed your dog or your cat. I don't care. Your cat can die of zinc poisoning, and it does not matter to me at all in this question.
Okay.
I know, I'm a horrible person, okay? Don't get me wrong. I'm a bad person. But I'm a bad person in the service of getting right answers on the GRE, and on the GRE, I care only about what they tell me to care about. They told me to care about pet parakeets dying, and that's it. And so I don't care about, quote, many kinds of household pets. I care only and exclusively about pet parakeets.
Okay.
All right. Let's do one more. How about this one? Oof. Bad kerning kills me. Cat, I know I just said you could die of zinc poisoning, but that doesn't mean you get to be on my computer. Sorry.
You're good.
My cats love me.
That's good. Um, okay, questions?
Just so we're clear, what was the conclusion here?
That I don't remember their names, but that
The
they,
governors.
yeah, the governors made secret agreements before Sturbins was elected.
So, what's the evidence of that?
Um, so the new governor came and a bunch of others retired, and Governor Sturbin was supposed to um, replace the retired governor, retired officials.
And he did it using
Um,
the other guy's people.
old. Yeah, yeah.
So the evidence that they colluded is that Governor B promoted a whole bunch of Governor A's people, right?
Yeah.
Everyone Governor B promoted was a Governor A person. Now, the gap here is that's one possible explanation, but maybe there's another reason, right? Like, maybe that's why he promoted those people because they had a secret agreement. Maybe it's not why. I don't know. See if you can weaken it. Maybe there's another reason.
Um, what? Can you go back really quick?
You got it.
So, can you go back to the questions? Um, so B doesn't do anything. It doesn't ever talk about um, the opposition between the two. Um, so that's not it. Um, uh,
So
I
again, what?
like
Sorry, you like what?
I like A because it's talking about the productivity, but I don't know it, if it is enough connected because it's talking about a secret.
What question are
That
we trying to answer?
um, we're trying to weaken the idea that Baxter and um, had a secret agreement.
So what question do we need to answer then in order to
Did they have a secret agreement?
Yeah, but like, well, sure, of course, but like, how would we evaluate that? Like, what made me think they had a secret agreement?
Um, that all the people that were promoted were hired by Baxter.
Servants promoted Baxter people.
So
Now,
they
one
kept,
explanation is they had a secret agreement.
yeah.
But if that's not the case, then what question do we need to answer? If Sturbin didn't promote Baxter people because of their secret agreement,
Why did he promote
right,
them?
right, that's the question we need to answer. If it wasn't because of a secret agreement, then the question we need to answer is, why did Sturbins promote Baxter people if not for the secret?
Productive, like question A or answer A.
Well, but A is a little bit disconnected, as you pointed out,
Yeah.
right? Like, it's a maybe, but did he promote Baxter people because he knew that productivity would rise? Could he have promoted his own people and had productivity rise?
Yeah.
Um, like there's a lot of kind of still questions lingering.
And then C, he's saying, um, I mean, all of them were hired by Governor Baxter, so it doesn't matter. Even if they had a secret agreement, it was already hired
Let's assume they didn't have a secret agreement. Why did Sturbins promote Baxter people?
because they were all hired by Baxter.
Because they're all Baxter people,
Yeah.
right? If you're going to promote anyone, you're going to promote Baxter people. They're all Baxter people, right? The rules say the governor was tasked with replacing them by promoting current state employees to the open position. So great, you're Governor Sturbins. Who are you going to promote?
All the Baxter people.
Because you couldn't possibly not.
Yeah.
Does C definitively answer the question, why did Sturbins promote Baxter people?
Yeah.
And does it say it had nothing to do with a secret agreement if there was any, and there's no
Yeah.
reason to think there was?
Yes.
And you see that that is much more direct than A.
Yeah.
Like A kind of says, well, maybe he thought they were good people and he was right and they were productive and that's why productivity has risen. So the fact that productivity has risen means that they were good people and he knew that and that's why he promoted them and he couldn't have promoted anyone else who would have been equally productive. Like there's still like all these extra steps you got to fill in.
Yeah.
But he just says like, why did he promote Baxter people? Because he had to. That's why. The end. That's all there were.
Options. Yeah.
Yep, and that's the answer.
Okay.
So if you can go through and identify what exactly the gap is, in this case, they moved from what happened to essentially talking about why it happened. What happened? He promoted Baxter people. Why? Well, maybe they conspired. And when you go from what to why, the question you always have to ask is there another potential reason? Could it be some other reason? And once you recognize that gap, then it's finding another reason to weaken it. And that's it. Okay, any questions about critical reasoning?
Nope.
Feel okay about it?
Yeah. I'm gonna do more practice problems with it though.
Of course, as always. Let's take another slightly short break here and get a little early into the math in about 5 minutes.
Okay.
All right, see you in a bit. And we're back. Hey, how's it going, Aaron?
Oh, splendid. Ready to do some math.
I'm excited. Great. I'm glad you're ready for some math. Okay, so today we're going to talk about statistics, probability combinatorics, and maybe some Venn diagrams, and that's a lot to cover, so let's get straight into it. Data analysis, also known as statistics, um, is a significant part of this test, but ultimately we're not talking about a very high level. You basically just need to understand mean, median, mode, range, and standard deviation, those five topics, in a pretty straightforward kind of middle school way. So, do you know what all five of those things are? Mean, median, mode, range, and standard deviation?
Yes. Standard
Uh,
deviation is iffy. It's been a while since I learned about that, but should all
okay.
remember.
Well, the good news is you don't have to be able to calculate it. You just need to understand conceptually, sort of qualitatively, what standard deviation is. It's a measure of how spread out the set is. Now, the mean is simply the average. It's the total divided by a number of items. The
Mm-hmm.
median is the middle number in the set. Now, if there's an odd number of terms, there is a single middle number. And we saw that last time, right? With 167 items, there was a single middle number that was the median.
Yes.
If there's an even number of items, there will not be such a single middle number. Instead, we'll take the two middlemost numbers and average them to get the median. Okay?
Yeah.
Um, Now, the mode is the most frequently occurring number in the list, but if everything shows up exactly once, there is no mode at all. Or it's possible to have multiple modes if there is a tie. Finally, the range is simply largest minus smallest. Make sure you put the set in order to get the range. So you can practice this on your own. You'll have these handouts and you can go through and calculate mean, median, mode, and range. I don't really feel like it too much right now. Standard deviation is how spread out your set is. The more spread out, the bigger. Now, you don't need to calculate it, but you do need to understand it conceptually. If your set is all clumped in the middle, your standard deviation will be very small. If instead your set is way spread out on the ends, your standard deviation will be much larger. That's the kind of thing you need to be able to do. Which set has a higher standard deviation? This one or that one?
Um, the one on the right, or no, the one on the left. The
Right,
1778.
that's correct. These guys have very similar averages. I don't know exactly what it is, just eyeballing it. Maybe it's like five or so. We could sit and calculate it. I mean, this one is 25 over five. This one has an average of five, the one on the left, and this one has an average of 5.4. It looks like. And if you start looking, well, these guys are all really far from five. Like, this is four away, three away, two away, two away, and three away. Nothing's closer than two away. But these guys, this is like from the average, zero point 0.4 away, zero point 0.4 away, zero point 0.6 away, 1.4 away, like 1.6 away. Like, all of these numbers are closer to their average than any of those numbers are. So
Yeah.
clearly the larger standard deviation is on the left. Make sense?
Yes.
And again, that's the level of work we need. We do not need great detail and calculation. We just need to understand conceptually. Let's have a problem that brings together some of the ideas of mean, median, and range. Try this one.
Um, I don't know how to approach this.
Okay. If there are 17 different integers
Yes.
and the median is 44, how
Yes.
many integers are here and how many are there?
8 and 8.
Right, 8 and 8.
I
Now,
got
these 8 must all be less than 44. These 8 must all be greater, right? Now,
correct.
if I want the very last number right at the end here to be as large as possible,
Yes.
then what should I do with these numbers here? Should I make them generally large or generally small?
Small. Oh,
Remember, my range is 45.
larger, I guess.
Right, given that I have a fixed
Can be
length
larger.
of the set, if I pull this one to the left, I'm going to pull everything to the left. If I pull this one to the right, I'll pull everything to the right. You see?
Yes.
So I'd want these to be as large as possible. What's the largest any of them could possibly be?
Um, oh, different. So 43.
Different integers, 43. And then the next one?
42.
Right, and then
41. 40.
39, 38. There's not that many. I'm just going to list them. 37, 36, right? And
Yeah.
that's
So
8. That's 8.
the, okay, sorry, go ahead.
No, no, after you.
So, I just tried I don't know if this is the right way to approach it, but I just going off of that right there, I just jumped into using the numbers they give. I started with 89 because that's the biggest, and I did
Yeah, I
89
wouldn't look
times
at
43, which is 46,
that. No, no, not
46. So it's not the range. So I went to 88. Not
not
how you do.
necessary at all.
Okay.
Look, these are the biggest 8 numbers you could get, right?
Yep.
And if this is the least number in the set, and the range is 45, how would you get to the greatest number?
45 plus 36.
Yeah, what would you get then?
81.
There is no need to try answers.
Okay.
The answer is 81. And you can, but you're making your life harder. And remember, part of this is not just being able to get the answer, it's being able to get it very quickly and efficiently. You have a minute 45 seconds average on these questions, and you need some of them to be significantly faster. This is a question, ideally, that you want to get into pretty quickly and beat under that time. So if you're sitting there trying answers, you're probably not going to gain the time that you should gain.
Okay.
Does it make sense, though, how we did it?
Yes.
We started from the median, and we focused on, if I want this to be the greatest possible, sorry, I've marked this all up, but if I want it to be the greatest possible, then I should make the smallest number as big as possible, since the range is fixed. And then I just looked at the fact that there's different integers, and I said, okay, well, how big can I make those little numbers as
Minus
close
8.
to 44 as possible? And I just listed them out.
Okay.
Okay. This is a funny question because it says standard deviation. It's not so much about it. Let's talk through this one together.
Okay.
If the mean is 5 and the standard deviation is 3, what is 3 standard deviations below the mean?
2.
Why 2?
Well, I'm just going off of if the mean is 5 and if it's below the mean,
So then you're subtracting.
yeah,
What did you subtract from 5?
3.
Why 3?
5 and a standard deviation because it's 3 standard deviations away from the mean.
Well, but that wouldn't that be 3 times whatever the standard deviation is? They said 3 standard deviations. They didn't say 3 below the mean. They said 3 standard deviations below the mean.
Oh, that's true.
See, the funny thing about this question is it actually does not matter what a standard deviation is or even what a mean is. if I said 3 flibberty gibbets below the weebledy wobble, this question would work just fine. Okay?
Okay.
Like, you'd be like, okay, what is the weebledy wobble? And then I'm going to subtract 3 flibberty gibbets. Fine. In this case, the weebledy wobble, also known as the mean, is 5. And the flibberty gibbets, also known as the standard deviation, of 3, right? Oops. Right?
Yeah. So it's 5 minus 9. -4.
That's right, -4. And again, recognize that this is just a word problem translation. It has nothing to do with statistics at all. But you had to be able to translate 3 standard deviations below the mean. That is different than saying 3 below the mean. That is 3 times whatever the standard deviation was.
Okay.
Clear on that?
Yes.
Okay. Let's keep moving. Lots to cover. Frequency distribution is a bar graph that shows things in frequency. You can also give this as a probability distribution, which takes it as a percent of the whole. So these are going to always add up to 1 then, because they're all decimals that make up the whole thing. This question is very much like the last one. I'm not going to help you as much with this one. Let's see if you can do it on your own.
Okay.
What you got?
So this is, I just did the exact same formula, so 85, well, okay, so 85 minus 2 times 12,
Right.
which equals 61. But what,
That would be the low end. What about the high end? It says
so
within, right.
then it's 85 plus 24, 90, 109.
So what are my answers?
Which I found numbers of sense. Well, 109 minus 61 is 48.
No, within this range. I don't know which of the numbers are within this range. Don't make it any harder. You've got this. Which of those numbers are within this range? Is 55 in this range?
No.
Is 60?
Oh, no. 65.
Is 100?
Yes.
Is 105?
But not 110.
There you go.
Oh.
That's it. I said don't make it any harder, right? Like, they want you to get the range and tell me which numbers are in it.
Okay.
That's it. Which of those numbers are in here? These numbers are in here.
Then the standard two standard deviations. Got it.
Don't overcomplicate it. Remember, the statistics here is not meant to be super, super high level. So it is dangerous to overthink.
Yeah, it always is.
Yeah. Okay. Okay, let's see. Other graphs. Mm, let's do this one. You know what the 25th percentile is, right?
Yeah.
Say that's. Yeah, okay.
Okay, so
Yeah?
um why don't I get your drawing of what you're put other than you just wrote it all out or
I just sort of showed you the median of A and the median of B, and the median of A is 15,000 greater. But, like, don't worry about it then. I can erase my drawing.
um if the median of city A equals 15,000 plus median of city B, just write that out. And then I don't really know what to do. How do you get the percentile, I guess?
I have no idea, actually.
You either. And
Yeah,
I'm trying to figure out a way
I
because
don't know a way.
me either.
Well, then I guess we should pick D.
Oh, god damn it. Okay.
Oh, no, like, that's it. I don't know either. Like,
Well, I
I
was
mean,
trying to do like the 50th percentile, but that's not the median. So then
well, the 50th
I don't.
percentile is the median, by the way. The median is the 50th percentile. They're the same thing.
It is?
Yes.
Okay, I thought that at first, but then I was like, well, maybe.
The median is the 50th percentile. The 50th percentile is the median. But here's
Okay.
the thing. Set A, I've got the median here, but could set A have all of its other points, here, and then a bunch of points like here?
Yep.
And could set B have all of its other points like here, and
Yep.
then like here?
Yep.
In which case, the 25th percentile of A is like here, and for
Yeah.
B it's like there.
Yes.
So B's 25th percentile could be way more than A's, even though B's 50th percentile is way less.
Yeah.
Or it could be the other way around.
It is a tricky one. I'm glad I didn't know. I was very lost. I was like, should I know how to do this?
No, no, you totally shouldn't. That's the point. I have no idea. Like, the point of this question is the location of the 50th percentile tells you basically nothing about the location of the 25th percentile. All it tells you is the 25th percentile is less than that. How much less? Where less beats me. It doesn't even have to be the same relative amount less in two different sets. Like, one could be like the 25th percentile is way less than the 50th. The other could be, oh, it's very close to the 50th. Tells you nothing.
Okay.
Yeah. So good job not knowing. That's exactly the right thing to do. Okay. How do you feel about the stats stuff?
Um, Good. Like I get it. Um, I
As
need to,
always, I know you want more practice. That's fine.
yeah, I'll practice more and see if I get lost. These are good exposure problems, though.
Great. Let me jump down now to some of the combinatorics. I'm going to do this all out of order. Okay. So let's talk about combinatorics. This is the fancy name for this. It's called combinatorics, but that's a big scary word, right?
Just a little bit.
Did you ever take a class on combinatorics?
No, not that I know of.
Ever take a class on stats?
Yes.
Yeah. Now, you know what? That's interesting because that's what always people say. Everyone has taken a class on stats, like no one has taken a class on combinatorics. And that makes this topic a little scary because people just haven't had the same exposure to it. But it doesn't have to be because ultimately combinatorics is no more difficult or high level than statistics at a middle school level. It's just you haven't seen it when you were in middle school. But if you had seen it, you would be looking at it like, oh, it's like doing arithmetic or something. Combinatorics is the mathematical study of counting.
Oh.
Combinatorics answers the question, how many ways can I blank? How many ways can I arrange these kids in a row of seats? How many ways can I choose people to be on my basketball team? How many ways can I buy a Happy Meal at McDonald's? These are combinatorics questions, okay?
Yes.
And because combinatorics is so fundamentally about counting, something called the basic counting principle, fundamental counting principle, is very important. The fundamental counting principle, basic counting principle, call it what you like, says two things. It says, and means multiply. The word or means add. The word and means multiply. The word or means add. Okay? And I
Okay.
understand that this principle may be, at first, a little unintuitive or counterintuitive because I understand that this is not the same basic principle that you have used in other areas. For instance, you're probably very used to the idea that and means addition. And if you were talking about algebra, you might be right. But in this field, and for the rest of this afternoon, and is going to mean multiply, and it's actually or that means the addition. Okay?
Okay.
So if I had two things I wanted, like I want to buy a Happy Meal and there's 8 choices of sandwich and there's 5 choices of side, I'm going to choose a sandwich and a side. I'm going to multiply 8 times 5 and I'm going to find out there's 40 different Happy Meal choices. Make sense?
Yeah.
So, like, there was a restaurant a while back that had this TV commercial that was like, you get for our new like dinner, deal, you get like an appetizer and an entree and a drink and a dessert. And they're like, there's over 10,000 menu combinations. Oh my gosh, 10,000 menu combinations. And I'm sitting there and thinking, you're saying, wait a minute, appetizer times entree times drink times dessert, I'll use Z for dessert, whatever. That product is 10,000. Oh, you mean like 10 times 10 times 10 times 10? They make their menu seem so fancy. Oh, there's 10,000 menu combinations. But and means multiply, you're choosing one of each, so really they could have 40 things on their menu.
Mm-hmm.
Ooh, wow, you've got 40 things on your menu, aren't you special? But it's funny because the multiplying makes it grow very quickly. Okay, this principle is very, very, very powerful, and it will solve a lot of your combinatorics problems by itself. Just when in doubt, think about whether you're adding or multiplying based on whether you're doing and or or. Now, that's not quite all, but before I go too much into the framework, I do need to do a couple of other basic things. You know what a factorial is?
Yes.
Okay. Like n factorial is a product from 1 to n, so 5 factorial is 5, 4, 3, 2, 1, which turns out to be 120. I strongly encourage you to memorize at least up to 5 factorial,
Okay.
and maybe 6 factorial as well. 0 factorial, by the way, is 1. Don't ask me why. It's 1 because I said so. 1 factorial is 1. 2 factorial is 2. 3 factorial is going to be 6. 4 factorial, 24. 5 factorial, 120. And if you want it, 6 factorial is 720. Oops, not 702, 720. Got that math dyslexia. Now, you'll note that if you have to divide factorials, 8 factorial, 876, 876, 5, 4, 3, 2, 1, and 6 factorial, 6, 5, 4, 3, 2, 1, they cancel, right?
It's 8 times 7.
Yeah, 56. Don't ever multiply out a fraction with factorials in it until you've canceled everything from the bottom. Because remember, combinatorics is counting. Counting means integers, and integers means everything from the denominator will cancel out. Make sense?
Yes.
Okay, great. Throughout the evening or afternoon, I'm going to be using n to represent the number of items. N items, k, x. N items, k, x. Okay? Now, there are two key questions you need to ask yourself whenever you are getting a counting problem. And the answers to these questions will tell you what type of a combinatorics problem it is. One is, does order matter? The other is there replacement or reuse of the items? You must always ask these two questions, order and replacement. Okay?
Yes.
Now, the thing about these questions is I find that they are not as automatic and intuitive as I would hope. So I've learned the hard way. I need to take a minute here to make sure that everyone, i.e. you, understand what these questions really mean. Let's start with replacement. Replacement means what happens when I pull an item. So imagine I have one of those big lottery ball spinners and all my items are in there on little balls and I pull them out. And so I pull out the first and I go B14. And then I do what? Well, if I throw it back in the ball spinner, shuffle it up again, and possibly call it again B14, just an arbitrary number of times. I can keep calling out B14 over and over. It's the worst game of bingo of all time. That is yes replacement. If instead I set it aside and say, great, we've done B14, I'm not doing that again, now I'm going to pull out a new ball, that is no replacement. Okay?
Yep.
Now, by the way, note that it's possible to just have two balls in the spinner that say the same thing. Like, I could have two balls that say A. That is not replacement, that is duplicates. That's a little different. With replacement, I ought to be able to keep pulling the same ball over and over an arbitrarily large number of times. Just as many times as I want forever, because every time I pull it, I throw it right back. Now, if on the other hand I set it aside, no replacement. So, got that question?
Yes.
Now, the order question is the one that really screws people up, I think. The order question is, if I take a particular outcome and shuffle it, any particular outcome and shuffle it, does it become a new different outcome? For instance, and if it does become a new different outcome, then yes, order matters. And otherwise, no, it does not. For instance, does order matter for license plates?
Yes. Or no. Well.
Which is
No,
it?
it does not matter.
Do you have a car?
Yes.
Do you have a license plate?
Yes.
Do you know your license number?
Part of it. I know the
Okay.
letters.
What are the letters?
SAE.
SAE?
Mhm.
Your license plate says EAS?
No, it says SAE.
It says ESA?
I'm saying yeah, so like the order doesn't matter.
Wait, no, no.
So it
You're
can
telling
change.
me that you're telling me that your license plate says SEA.
Okay, so then order does. I get what you're saying. I just didn't know if it.
Yes, that's order matters because remember, the order
But
question is
there could be whatever amount of people that have my 5, 6 digit slash letters,
the
but with
order
different
question
numbers
is
and
if
letters.
I shuffle your license plate, is it a different license number?
Yes. Yes.
Then order matters. If I
Yes.
can shuffle an outcome and make a different outcome, then order matters.
Yeah, I get it. I was saying it didn't matter in the sense that it won't. Yes, I get what you're
Yes,
saying.
you're allowed to have different orders,
Yes.
but the fact that the different orders are actually different license plates mean order matters.
Whereas
Do you play
if you do
basketball?
your, oh, go
Do you
ahead.
play basketball?
Do I play basketball?
Yeah, or have you ever?
I have.
So have you ever been on a basketball team?
Yes.
If I shuffled your basketball team, would it be a different basketball team? Same people, I just tell them to stand in different places.
No, we might not play as well, but
No, you're all out of position, but I mean, it's not a different basketball team, right?
yeah,
Order doesn't matter for choosing a team.
yeah. Or choosing your those 10,000 food options. It doesn't really matter because there's
Right.
some options that are going to be the same.
I mean, that one, it's kind of hard to even think of it as a yes or no order question just because they're so separate categories, right? Order usually comes when you're choosing multiple items from the same ball spinner. In that case, you simply have different ball spinners, each that has different stuff on them. Like, you've got a ball spinner full of 10 balls that all list out, like, appetizers, and another one that lists out 10 different entrees and whatever. So
Yeah.
that one kind of transcends the order question entirely. But yeah, I mean, if you're choosing a team, order does not matter. If you are deciding which books to pack for your vacation, order doesn't matter. You just want to know which books made it into your suitcase, right? Um, on the other hand, if you're trying to schedule your reading list, order matters, right?
Yeah.
Because then if you shuffle them, it is not a different selection of books, but it is a different schedule.
Hmm.
And they have to answer these questions, but note that they can answer them often with a single word. So with combinatorics, you have to pay attention, and you have to be open to nuance and be willing to look for specific details, and use a little bit of common sense here too. Um, if I say license plate, there's a certain amount of common sense required to say, I know how license plates work. I recognize that if I shuffle it, it becomes a different license plate. So order matters, right? And they may not say, oh, ESA and EAS and SAE are not all the same license number. But you're supposed to kind of know that. So pay attention to the wording. Like arrangement means yes order because it's a different arrangement if you shuffle it. But choosing things generally is going to just mean no order. A code means yes order because if you type your password in the wrong order, you don't get to read your email. Things like that. Still with me?
Yep.
Okay, so now let's talk about why we care. And the answer is because we have a couple different types of problems. And if the order does matter, we're talking about either a permutation or what I would call basic counting. Basic counting is the yes order but also yes replacement case. Permutation is the yes order, no replacement case. And then if the order doesn't matter and there is no replacement, that's a combination. So based on how you answer these questions, you're going to end up with either sort of basic counting or a permutation or a combination. Make sense?
Hmm.
Now, for permutations, there's no formula. I know you think there's a formula here, but I assure you there is no formula under the purple scribbling. Okay? There's nothing under there. Don't look at it.
Okay.
All right?
Yes.
Because with permutations, fill in the blanks. If I have the worst game of musical chairs ever and 8 kids and 3 seats, well, then I'm going to lay out 3 blanks. And in the first seat, how many kids could possibly sit there? 8 kids originally. How many choices do I have for who goes in the first seat?
Well, 7. If you're playing musical chairs, there's only one. There's usually one
Well, no,
less.
no. I mean, there's still 8 kids playing. You haven't played musical chairs in a while, right? You take out seats, not people. Like you still have
Usually
8.
there's one less seat than people.
Well, no, there's 8 people and 3 seats. It's a terrible game of musical chairs.
Oh, eight
It's
people and
like
3 seats.
a
Oh,
brawl.
okay.
It's going to be a giant brawl for these 3 seats, pretty much.
Yeah.
But how many people could go in the first seat?
3.
Well, but how many people are available to
Oh,
go in the first seat?
8.
8. And then for the second seat.
7.
And then?
6.
And then everyone else has to stand and loses musical chairs. And this is
Yeah.
and. I'm going to put them in the first seat and the second and the third. So that's it. That's a permutation with 8 people and 3 seats. Did we need a fancy formula for that?
No.
No. Fill in the blanks, right? That's all there is to it. 8 kids, 3 seats, 8, 7, 6. The end. Move on with your life. On the other hand, when the order does not matter, we have a combination. And for that, we do need a formula. So memorize this formula. This is actually something you can't get just by filling in the blanks.
Okay.
N items, choosing k of them, n factorial over n minus k factorial k factorial. Or they wrote it in the other order, but same difference.
Mm-hmm.
Let's do 1 or 2 problems.
Okay.
Great, let's do this one. Go ahead. So what's up?
Okay, so I laid it out. So the first one's digits,
Does order matter?
letters. What?
Does order matter here?
Uh, yes.
Yes, it does. Same digits in a different order represent a different code.
Yeah. So I got,
Is there
uh,
replacement? Is there replacement?
um, yes.
Yes, may be repeated. This is basic counting. So we're just going to fill in some blanks. 2 digits followed by a letter, or 3 digits followed by a letter.
Mm-hmm.
Okay, so you laid it out like that, right? Tell me more.
Then there's 10 options for digits. So it's 10, 10, and then 26 because it ends in a letter.
What do I do with those 10, 10, and 26? Add or multiply?
Multiply.
Right, because it's and. I'm going to choose a digit, and then a digit, and then a letter.
So
What
that's
about over here?
same thing. It's 3 digits, so it's 10, 10, 10, and then 26.
And again, I'm multiplying.
Yeah.
So then what do I do with the two numbers that result?
Then you add those together. So you got
Why do you
2600.
add them?
Why?
Yeah, why add?
Well, multiplying would be as though that would be one whole number, but it's two different codes.
But it's
And,
or. That's the key.
oh,
This
okay.
or right
Or.
here. Because look, sometimes I choose two different codes, but I want to choose the first code, and then I also want to choose the second code.
Mm-hmm.
And I would multiply. But I don't want to choose both. I want to choose one or the other. That's why I add. What's the answer?
Add D.
That's correct. Sorry to be kind of a stickler, but I just want to make sure the process is really good, because that way you'll be super consistent every time.
Okay. No, that's good.
Great. Let's do one more. You did really, really well with that one. You did great. One more. Here you go.
Okay, so I got 126. So I would pick D. And so I did 9 factorial over 5 factorial times 4 factorial.
So what you're doing here is, first of all, does order matter?
No.
Because it's selections. If you
Yeah.
shuffle it, it's not a different selection. Can you reuse the keys? Could I select the same key 5 times?
Yeah.
Really?
Oh,
How
well,
would that
no.
look? How would you put 5 of the exact same key on your keychain?
Well, you'd look like a janitor.
You really can't, right? You'd have to
No.
have 5 distinct keys. So this
Yeah.
is a no-no. This is a combination. That's why you're using combination formula. And this is, I've got 9 keys. I'm choosing 5. And this is 9, 8, 7, 6. Then the rest of that kills the 5 factorial here, leaving
Mm-hmm.
4, 3, 2, 1, the 4 factorial. And then 4 and 2 makes 8, kill the 8. 3 goes into the 9, makes 3. 3 times 7 times 6, 7 times 6 is 42, times 3 is 126. But wait a minute, that's not an answer choice. What's
Yeah.
the deal?
Well, okay, so that's figuring out how many um, total okay, this is where, okay. So I knew that wasn't the full answer. I don't think, because it says you're looking for at least one key for an exterior lock and at least one key for an interior lock.
Right. And
Um,
what are we going
and
to do
it's
with
looking
that
for,
fact?
say it again?
And so what are we going to do with that fact?
See, that's where I got stuck. I knew I got 126, and that's saying how many combinations are there with of 5 keys, or if you have a selection of 5 keys, but that doesn't necessarily say that there's one exterior, one interior. So I don't
Well,
know.
this is all the possibilities. One tool we could use is, if we know the total and we subtracted just the bad outcomes, what would we be left with?
The total is 126 minus.
Well, just conceptually, put the numbers aside. If you had all the outcomes and you subtracted just the bad outcomes out, what would you be left with?
What are the bad outcomes?
Put that aside. Like,
Oh,
if you took out the outcomes you didn't want, what would be left? Just the good ones, right?
yeah.
Do you agree that total outcomes minus the bad outcomes would equal the good outcomes?
Yes.
Okay, so let me go back to your question. What are the bad outcomes? What kind of
Um,
key selections would make you unhappy?
2 for the interior, or like multiple for,
That's
no.
fine.
Oh,
It says at least one of each.
so not one of the other.
So, like, how would that look?
If you had multiple for the interior, but none for the exterior.
How many for the interior? Remember, you got to choose 5 keys.
Oh, 5.
So you could have 5 interior and no exterior. That would be bad, right?
Mm-hmm.
How many ways can you actually achieve that? How many ways can you have 5 interior keys and no exterior keys?
1.
Actually, 0. There are only 4 interior keys.
Oh.
It's quite impossible. You
Ah,
can't have only 5 interior keys.
it's
But now
0.
let's try it the other way. How many ways can you have 5 exterior keys and no interior keys?
Now that's 1.
That's one. There is one way to do that. You take all 5 exterior keys and none of the interior keys. That can happen one way, which leaves 125 that are actually okay.
Gotcha.
So this was a little trickier because you
Yes.
had to subtract. Now, if it had been there were 6 exterior locks, you would have had to say, well, how many ways can I choose 5? I'd have to do 6 choose 5, which would be 6 factorial over 5 factorial, 1 factorial. If there were 7, you'd have to say, okay, 7 choose 5, right? 7 factorial over 5 factorial, 2 factorial. So like it could even be a little more complicated. But the point is, we calculated the total number of ways to choose 5 keys, and then we subtracted out the ones that were either all interior or all exterior because those would have been bad outcomes.
Got it.
Minus bad gives us the good. Any questions about that?
Yeah.
Okay, so that's combinatorics. We are moving right along. How do you feel about it?
Feel pretty good.
Again, I know you'll want to practice. Now let's talk about probability, and then hopefully at the end we can do Venn diagrams. Actually, you know what? I'll probably mm, mm, give me a second to think here. Let me quickly talk about Venn diagrams now, and then I'll jump into probability. I think I should have time. Okay. Sometimes we want to talk about overlapping sets. You could be in group A, you could be in group B, maybe a little of both, maybe neither. In that case, you generally want to draw this sort of picture, this sort of Venn diagram, overlapping circles. And sometimes people memorize a bunch of fancy formulas, like all of these formulas, like this one, and this one, and this one, and this one, and that one, and all these different formulas. I don't tend to do that. What I would tend to prefer is to simply draw the picture and look at it and do some arithmetic. So, for instance, if you told me that you had a total of 100 people and 50 of them are in set M, well, first thing I would do is M equals 50. I wouldn't put that here because here looks like it's just on the left side. See the difference?
Mm-hmm.
So I just kind of say M equals 50. And if I have 75 people here, whoops, that's not supposed to be an M, that's supposed to be N equals 75. Now, from here, if I told you that there are 30 people in the overlap, let me see, does that work? No, that doesn't work. 40 people. Let's go with 40 people in the overlap. That's actually here, and I put 40 here. Now, how many people would actually go on the left side here if this is a 40 in the middle? How many people go here?
Uh, would it just be 10?
Yes, it would.
No, it
Yeah, it
would?
would. It would be 10. All I'm doing is basic arithmetic. I had 50, 40 of them are here. I'm missing 10 of them. They must be there. How many people go on
35.
the right-hand side? 35. Very good. Now let's see what I've got. I've got 10 and 40 makes 50, and 35 makes 85. Wait a minute. I thought I had 100 people.
Yeah.
Where are the missing 15 people?
Uh, not there.
They're not doing anything. They're losers who aren't in any of the groups.
Oh, okay.
And you see how I just kind of filled in the blanks.
Yeah.
Just did arithmetic and basically common sense. And you can do this backwards and forwards too, okay? Like if I had, again, 100 people here overall, and then I told you that this is 50, M is 50, and I told you this is 75, N is 75, and I told you there's 15 people nowhere. You should be able to fill in the circles. Now you might say, how do I do that? But wait a minute. Let's be a little disingenuous for a minute. I have 100 people total, but only 15 are in. That means 15 are out. That means 85 are in, right?
Mm-hmm.
So I've got 50 people there and 75 there. So 50 and 75, that's 125 people, right?
Yes.
So wait a minute, now I'm confused. I see 125 people, but you're telling me there's only 85 people actually in. What gives?
Because there's overlap. People are counted twice.
Ah, because there's overlap, people are counted twice. And since I'm counting 125, but there's actually only 85, how many people got counted twice?
Uh, 20,
40.
40.
40 people got counted twice, because that's why you got 40 extra people, right? You counted these 40 people and you counted them again.
I see. Yeah, I divided into to
Yeah,
count.
right.
Gotcha.
No, the double count accounts for the full 40 people that are extra. And then from there you can get this 10 and this 35. So you see you can play this game backwards and forwards.
Yeah.
And that's important. And that's how you handle this. Now let me give you a not too terribly difficult problem, I hope.
I hope.
Let's find out. Try this.
Would it be C?
Explain that, please.
So P is 15, Q is 8, and the overlapping is 4. So P minus, or 15 minus 4 is 11, and 8 minus 4 is 4. And so I added 11 plus 4.
They wanted this and that.
Yeah.
Bingo. 15's correct. I told you I didn't think that was too terrible.
Yay.
Okay. You basically understand Venn diagrams?
Yeah.
We got a ton to cover today, so I know I'm moving real fast, but let me know if you're ever confused.
Well, I feel good about it.
Great. Let's keep moving. Let's talk about probability, our last topic of the afternoon.
Woohoo.
Yay! We might actually get all the way through this crazy lesson. I've never really done that before. I'm always leaving a little bit till the next time, but we might make it today. Great. I think it helps when it's just one person because, like, if it's multiple people, then maybe on a given topic, not everyone's going to understand it, and I always have to slow down for whoever doesn't.
Yeah.
But now for you, I only have to slow down when you don't understand. Um,
Nice
okay.
situation.
Yeah, free private tutoring, like discount, super discount private
Yeah.
tutoring.
Quote unquote free.
Trust me, doing private tutoring with me would be way more expensive than you're paying for this class. You're getting a serious, serious deal.
Okay, okay.
You are.
You'll
Trust
show
me.
up.
You're lucky. And thanks for showing up. I really appreciate it. We really do.
Thank you for showing up also.
Oh, well, of course. Uh, okay. So the probability of an outcome is the number of desired outcomes over the number of outcomes total. All right? Good outcomes over total outcomes. And given that the good outcomes are a subset of the total ones, probability will always be between 0 and 1. Never, ever outside of that range. Okay? And a lot of times you can simply count the good outcomes and count the total ones. So let's start with a relatively straightforward probability problem. What is the probability that the student you select at random will have a height between 61 and 67 inches? How many good outcomes are there?
There's 10 desired outcomes.
How many total outcomes are there?
15. I
Okay.
just added. So it should
Right.
be 2/3. And
Right. And that's it. So probability in the basic sense is not that complicated. Just
yeah,
count the good outcomes and count the total outcomes.
yeah.
Okay? And that's it. Answer was C. Now, the fundamentals here are very solid, but sometimes they're not enough, and sometimes we need to use the basic counting principle. That's the and means multiply, or means add. But then you'd say, well, wait a minute, does that actually always work? Let's consider this. Imagine that I was interested in getting either somebody who had a height between 61 and 67 inches, or somebody who had a height between 65 and 72 inches. Now, I already know the height between 61 and 67 was 10 over 15, right?
Yeah. So then you add, what were the other numbers? Or, I'm sorry,
Between
the
65 and 72.
65 and 72 inches.
So that's here, right?
Yeah.
And
So
what's
it's
that?
9 over 15.
And so if you add them up, you find out you have a 19/15 chance of getting somebody in one of those two regions, right?
Mm-hmm.
Wait a minute. Does that make any sense at all? Is it possible to have a probability that's 19/15?
No, because it's outside of 0 and 1.
So then
So,
how on earth did this go horribly, horribly wrong?
well, you went 61 to 67 and then 65 to 72. So there's overlap, like you drew in the box. So 66 inches, there's 5.
Oh, and I double counted them, like in the Venn diagrams, right?
Yeah.
So like in the Venn diagrams, I need to then subtract out the overlap. Just like I did with the minus 40. Like, whoops, I got 125. It's actually only 85. I needed to subtract out those 40 people I counted twice.
So the answer is 14/15.
Right. And note, this is actually both in the range and makes sense. So what we've learned here is that the probability of A or B is not exactly probability of A plus probability of B. It's actually that minus the probability of A and B, the overlap, I need to subtract the overlap so I don't double count. Make sense?
Yes.
So the basic counting principle works pretty much the way that we talked about for combinatorics, but it has this small but very important twist. By the way, note one other way we could have done this is just to say who's not in either of those ranges. That's one person, right?
14 out of 15.
Ah, so if there's only 1 out of 15 that's bad, remember that we said total minus bad equals good. Well, the total is always 100%, which is 1.
Over 15.
And so you can take 1 minus the bad outcomes and get the good outcomes very directly in that way. Does it make sense?
Yep.
So we just learned 2 important tools here. One of them, if I scroll back down, this is I'm jumping all around. Generally, probability or means add, but if there's an overlap, I have to subtract it. And that's the rule we just learned right here, and you got a nice visual of why it is the way it is. So does this rule make total sense to you?
Yes.
The other rule we just learned, which is also very useful, is sometimes it's difficult to calculate directly. In our case, it wasn't that bad, but sometimes it's difficult. And in that case, we can do this. Because every event will either happen or not happen, the event or not event is guaranteed. So probability of E plus not E is 1. And that means the probability of your event is always 1 minus the probability of not your event. Make sense?
Yes.
And this is just a fancy way of saying good outcomes, your event, is the total outcomes, which is 100%, something's going to happen, I don't know what, but something, minus the bad outcomes, which is the same rule we learned over in combinatorics. And this is very useful because it allows you to calculate in the case where you have a difficult time to calculate directly, but an easier time to calculate conversely, like in the problem that I gave you just above. It was easy to say, well, just one person is none of these things. And that's easier than counting up all the people who are some of them. Make sense?
Yes.
So, let's see here. Now, by the way, generally the AND rule still works. AND means multiply provided that your events are independent. That is, the outcome of one event does not affect the probability of the other. So like flipping a coin and then flipping another coin. What happens on the first coin does not affect what will happen on the next one, right? Those
Yeah.
are independent. In that case, the multiplication rule still works. Otherwise, if they're dependent, you have to multiply conditionally. You have to do, oh, well, what's the probability of the first thing? And then multiply it by what's the probability of the second thing, given that the first thing already happened. So the probability of drawing 2 aces in a row, what's the probability of drawing the first ace? You know how many cards are in a deck?
52.
And how many aces?
4.
Okay. And then what's the probability of drawing a second ace?
3. 51.
Right. And that's how you would do it if they're dependent. Just a slight change. Now, if you were putting them back each time, you drew an ace, threw it back in the deck, then it would look like this. These would be independent, right? See the difference?
Yeah.
Okay. This is a basic framework. Again, I'm trying to kind of hustle because I got a couple questions here. I want to do, yeah, let's go ahead and do this one.
Okay.
What's up here?
So you just did 16, because you're looking for marketing, 16 over 60 plus 15 over 59.
Right. 16 marketing majors out of 60
That's
total, 15 out of 59. And then note you got canceling all day. You can take a 15 out of the 60 and get just 4. 16 over 4 makes 4 on top, and we're done.
Yeah, I was doing the math when you asked.
Don't do too much math here. Look for cancellation, okay?
Okay.
All right. Again, because we want to be quick. I'm not giving you a ton of time, but I'm giving you about a minute 45 on a lot of these, and you need to be on it. Ideally, you want to gain time on some of these. What if they just wanted at least one marketing major? They didn't want them both to be, just at least one of them.
But still two different students?
Yep.
Well, then the first one would be 16 out of 60. And then the next one would be 58 over 59.
Why? Which one student wouldn't be okay with you?
The one marketing. Like if you picked one marketing, then you subtract one, so that would be 59 people. So then you have 58 choices.
Wait, what 50? I mean, again, I don't understand. 59 people, but any of those 59 people are different than the first person. That's why you subtracted one and made 59 in the first place.
Oh, so 59 over 59.
This is close, but it's wrong. Do you know
Okay.
why?
Well, that would be one.
You're assuming that you picked the marketing student on the first try, but you didn't have to, right?
So should I have done, uh, should I, instead of, so should I do it over 40, or I'm sorry, over
You also could have picked the first marketing student on the second try, right? In
like
that case,
60 minus
any
60?
first person would have been okay, but then you would have needed one of the 16 marketing people out of the remaining 59, right? Right? Does this make sense or no? Karen? Can't hear you.